Hello, everyone, and welcome. Thank you all for joining us. And I'm the event planner for the Redmond Reactor. Before we start, I have a few things to go over. Please take a moment to read our code of conduct. We seek to provide a respectful environment for both our audience and presenters. We encourage engagement in the chat, but please be mindful of your commentary and remain professional and on topic. This session is recorded. It will be available through Microsoft Reactor YouTube channel in about 24 to 48 hours. I'll be sharing the link for our YouTube channel in the chat. I'll also be sharing the links for our Redmond Reactor Mira page and for our survey as well. Which brings us for our session today. This session will run for up to approximately 1 hour with time for questions throughout. Our speakers for today are Jim Bennett. He's a senior cloud advocate, and Sy Brand, senior program manager at Microsoft. I'll hand this now over to you.
Awesome. Thank you very much, Firas. Hello, everyone. Good morning, good afternoon, good evening, wherever you are in the world. Welcome to this second session of Jim Learns Stuff, where Jim relearns C++. So thank you all for joining. Once again, I am joined by Sy from the Visual C++ team here at Microsoft. Sy, do you want to say hello, introduce yourself?
Hey everyone, yeah, my name is Sy. I work as the C++ developer advocate for the tooling team. So I spend a lot of time speaking at virtual conferences these days and spending way too much time on Twitter. That's pretty much my job, just posting nonsense all day.
That's great though, when your job is to literally post nonsense on social media. It's kind of,
yeah,
it's a fun job, isn't it?
I mean, that's what I did before I got this job, and now I just get paid for it. So
yeah, that's true. Actually, I'm kind of the same. I was posting mobile nonsense, Xamarin nonsense back in the day on Twitter, and then they offered me a job to do it professionally. It's great.
Yeah.
So today is all about C++ tooling. If you joined us last week, we dived into introduction to the language. So I had a lot of fun last week. A lot of folks were just chiming in, chatting with us. It was really, really good session last week, just chatting with everybody who was on the stream. And so we didn't get anywhere near as far into the language as we were hoping, but we had a lot of fun with everyone. Today, we're kind of going to take a bit of a step back and think about the tooling that you need to kind of get started with C++ and kind of get yourself going. But first, I do want to say hello to Ravi, who's saying hi there. Hey, Ravi, how you doing? Are you a C++ developer by any chance? It'd be great to kind of know what your background is. In fact, same for everyone here. Please dive in the chat. Let us know whether you've done a lot of C++, whether you're new to it, whether you're new to doing it with Microsoft tooling. Let us know what you've got and what you've done. So today, it's all about diving into tools, but please ask the questions. We can kind of take the conversation in whichever way helps you. If you've got any burning questions about what tools to use, how to get started, please just ask your question in the chat and we'll do our best to help out and get some answers for you.
Yep.
Cool. So Ravi says not lately, 5 years ago. So that's slightly better than me. If you're here on the last session, Ravi, I did confess to the fact that I used to be a really good C++ programmer 20 years ago. Since then, I dabble a little bit with embedded development. But luckily Sy's here. Sy eats it, lives it, sleeps it, breathes it. So I'm glad we've got an expert on our side.
Glad to be here.
Yeah, cool. Right. So let's dive in. We're talking about tooling. The areas we want to talk about today is how you get started on Windows with Visual Studio. We're going to dive a bit into Visual Studio Code for cross-platform development. It's early in the morning. I can't speak proper. For cross-platform development, we're going to look at VS Code, and then we're going to talk about VC Package, which is what I gather a very amazing tool for stealing other people's code.
Exactly. Yeah, put nicely. Being nice about
it. Stealing is the wrong word. Using other people's code that they very kindly agree to share. Borrowing. Yes. Cool. So I guess let's kick off with Visual Studio. So, Sy, you're the expert here. I've just created one project. what can Visual Studio offer us as a C++ developer?
Sure. So if you download Visual Studio, you might be met with a bunch of these options. Even before this, you need to pick which version of Visual Studio you want to download. So right here, I can see you're using the Community Edition, which is free and has some licensing constraints. And then there's other versions as well, like the Enterprise version, which has a few more features, and you can use it for like large scale enterprise development. And then once you download the installer, you're met with this page, which you see here. And there's a bunch of different options. So not all of this is C++, of course. You can see Python there, you can see .NET, but you can see the desktop development with C++ is checked there. And then there's a few other options as well. If you scroll down, like targeting, like mobile development, you can see there. There's one for game development, which is probably just off the screen. Yeah.
There we go.
And then there should be one for Linux development, I believe. Yep, right down at the bottom. Linux and embedded development. So any of those.
Quite a few options there.
Yeah. And then in addition to those like main workflows, there's individual components, which you can see over at the right-hand side. So that's things like, you can see address sanitizer is ticked there. That's for finding memory corruption bugs. You can see live share there, which we used last time to so that I could make modifications to Jim's code without having to like download everything myself and marshal all the data around. You can see the CMake tools there. And then there's a few things which are not ticked down at the bottom by default. So for example, if you want the Clang tools for Windows, i.e. the Clang compiler and Clang tidy and all of that stuff, then you can go ahead and check that. If you want Incredibuild for doing distributed builds, then you can tick that. There's a bunch of additional options that you can enable there. So
cool. I have questions. I have questions on,
go ahead.
on all of this. Before I do though, John Mason says, I was a C++ programmer a long time ago also. I do much more C# and related technologies now, but want to get back to basics with the new tooling. Nice, John. Well, hopefully we'll better answer any questions you got about the tooling. Hopefully we better help you get up to speed. And it's good to hear you're coming back into the fold.
Yeah.
But yeah, I have questions on all this. As I mean, there's a lot here. There's a lot of options here.
Exactly, yeah.
So some I know about, like MFC. That used to be how, I guess probably still is, how you build Windows. I cannot speak today. Windows desktop applications in C++.
Yeah, there are more modern versions now, but MFC is still supported.
Yeah. Lots of macros of putting things in that was very, very scary. But I must admit, you mentioned CMake and Clang. Now, I've heard those words. I have heard those words, but I don't really know what they are. So, what is CMake? I'm assuming it's something to do with making the code, kind of like old-fashioned make files for building code. But yeah, what is it? What does it do?
Yeah, so CMake is a build system for C++, which is cross-platform. So if you have a CMake solution, then you can build your code on Windows or Linux or macOS, or for targeting some embedded system, whatever. As long as your code isn't using any like platform-specific stuff, then you can build anywhere. So that's the point of CMake. So you have a description of how to build your code, and then CMake can generate you a build system from that. It can target Windows Visual Studio solutions. It can generate make files for you if you want. It can generate build systems targeting a bunch of different systems.
Gotcha. Yeah, because I know later on we're looking at how we can do all this on other platforms, because this is Visual Studio, this is Windows only. So if I wanted to write some code here to run on another platform, if I did it as a Visual Studio solution, I couldn't do it on Linux or Windows. But if I use CMake, I can.
So there is MS Build support for Linux as well, but yeah, CMake is the preferred option for doing cross-platform. So if your host system, the system which you're writing the code on, is in Windows, then you can use CMake to target any other system.
Gotcha. Comment from Gnarly Duck. Just wanted to say thank you for sharing your knowledge. You're most welcome, Gnarly Duck. We love this kind of stuff here. It's great to be here and actually share what we know, or in this particular case, share what Sy knows with everyone here. So no, you're most welcome. And I will put a chip in now. We do run surveys with all our live streams. So please, if you like it, let us know. But also, please let us know what other knowledge we can share with you. Please, let us know that when if you see a survey link come through. But no, thank you, very kind words. So yes, a clang. I've heard that term clang a lot. I use a Mac, and you see clang referenced on a Mac. And I keep hearing about this LLVM byte code and clang and all that kind of stuff. What's that all about?
Yeah, so LLVM is a compiler framework, I guess you call it. I don't know what their official marketing term these days is, but it's a system for building compilers, essentially. So you mentioned LLVM byte code there. LLVM byte code is a representation of what's called LLVM IR, which is a representation of a program. It could be a representation of a program which was originally written in C or C++ or in Rust or Swift. But that code is then translated to this intermediate representation and then translated to your machine code like x86 or ARM or MIPS. Maybe I can't remember if there's a MIPS backend for LLVM, but basically it's a compiler framework, and Clang is the C++ compiler which targets LLVM.
Right. I guess Clang is C-Lang?
C-Lang, yes.
Right. Okay. So if you think about sort of .NET, I mean, like John was saying, is now a C# programmer. When you kind of build a .NET application, you get .NET bytecode, essentially, don't you? Same with Java. When you compile that, you get Java bytecode. So this is kind of the same thing, but it's a much more low-level bytecode that compiles to machine code. Is that a fair assessment?
Yeah, similar. The translation's happening at a slightly different time, and it's you don't ship LLVM bytecode to anyone. It's just a format which is used for representing the code in an intermediate state, which then is essentially immediately compiled to your target machine.
Which I guess makes sense, because otherwise you think you've got to build a Rust compiler that takes Rust code to machine code for Mac and Windows and Linux, x86, ARM and all that, and then every time a new platform comes out, you've got to add another compiler, and you've got to do that for Rust and C and C++. Whereas if everything just compiles down to this intermediate representation, then you just have one intermediate representation to the chip compiler that's optimized for that chip. Then when you add a new chip, you don't add a new version of Rust, a new version of C, a new version of C++. You just add a new intermediate level compiler.
Yeah.
Nice. And I do want to I want to dive into some credit build as well. So this, you say this is distributed builds. I know we're talking last week about the difference in modules and header files. And I was mentioning that the place I worked at, we had one header file that when you changed it, it took like an hour and a half to recompile. So there was talk back then of tools where you could use everyone's machine to build. So those folks in the office who were just, you know, managing spreadsheets and not really using their CPU, we could build our applications on their machines as well as our machines to kind of make it faster. Is that basically what Incredibuild is?
Yeah, that's basically what it gives you, acceleration of your builds across multiple machines, so that you don't have to just build everything from scratch on your machine whenever you want a clean build of your application.
Cool. Yeah, because especially with huge projects. I've no idea how long it takes to build. I know this is C, but Linux is C based. So I don't know how long it takes to build Linux. But if you're building any large applications like that, it's C++ compilers are not fast compared to Python, where it just runs. So having this kind of build thing sounds like a very, very useful piece of functionality to have.
Yeah, it can be. And we are doing a lot of work on the performance of the compiler and the linker, especially recently. So build throughput on individual machines is improving dramatically still, but with very, very large projects, it can really help having that that distributed nature of build acceleration.
Yeah, it always makes me think of that classic XKCD cartoon where there's two people on wheelie chairs having like a sword fight with sticks, and there's a shout from the office, get back to work, and like, we can't, our code's compiling. Yes. So John has a question. So LLVM has replaced MSIL. Do I get cross-platform capabilities from LLVM?
So LLVM is not a Microsoft project. LLVM is an open source project which can target Windows. So it can also target Linux and Mac OS. And we at Microsoft have contributed to LLVM and Clang and helped the compilers all work on our systems and things like that. But it's not a Microsoft project.
Yeah, because MSIL, that's the intermediate language for .NET, isn't it?
Yeah.
Yeah. So that's very different, because you ship MSIL and that gets just in time compiled on the machine, whereas LLVM, the bytecode is compiled at compile time.
Yeah, and if you're a user of LLVM, you shouldn't really have any need to see LLVM IR or know that it exists. Really, it's mostly for compiler developers.
It's just part of the compile step. You hit compile and it just happens. Whereas the IL is something you ship, and they've got tools like IL Explorer to actually dig into that, don't you?
Yeah, I mean, and there are similar tools for LLVM, but they're targeted at compiler developers.
Yeah. So the average mere mortal who is not that smart, just doesn't care, just clicks build and it builds. And Adicola says, hi. Hey, welcome. Welcome to the stream. Glad you could be here. Cool. Okay, so we looked at some of the options for C++. There's a lot here. I mean, I just checked the desktop development because I want to have something installed for today. You do not want to see me just sit here watching an installer go. But it seems like there's a lot of options for C++ in Visual Studio, and then kind of a lot of powerful things we can add. All the profiling tools and test tools, and then lots of other cool bits and pieces.
Yeah,
so
but the defaults should be good enough if you want to just get in and get started. Just hit the desktop workflow for C++ and off you go.
Yeah, that's what I had here last time when we did the Hello World. It just seemed to work. So here I am in Visual Studio, and let's talk about kind of the whole file new experience. So if I go file new project, can I make this window? Let's try and make this window a bit bigger. Come on. It won't let me make it bigger. Yes, it will. Yay. So if I go create new projects, I've chosen C++. And so I've got an empty project. I've got a console app, CMake, Windows Desktop Wizard, Windows Desktop Application, DLL, static libraries. There's a lot here. Makefile projects. So I guess the two biggest ones to think about for right now, I guess for beginners, would be a console app and a CMake project.
Yep, absolutely. So a console app the console app template will give you just Hello World application, which targets Windows and builds using MS Build, which is the build system which has been in Visual Studio for many years. And if you choose the CMake project, then that will generate you just basic CMake Hello World program, which you could then compile on Windows or Linux or somewhere else.
Okay. I have to just point out, Jumpman Stickers just joined us and says, "Oh, C++. Cool." So
I agree.
looks like we've got another C++ fan in the room. Welcome. Glad you could join us. If you've done much C++, please share your stories. It'd be great to hear what you've been doing. Okay, so a console app. This would be an SLN file. This would be a traditional Microsoft solution file, and that solution file contains all the stuff. So, let's just create one of these for now, just to kind of compare the two, really.
Mm-hmm.
Console application 1. Give this a second. So this is, where's my thingy window, my solution explorer. So this is where I've got, so this is created the solution. This is the traditional .sln file. And I've got all these folders here for source files, header files, resource files. Kind of if you've done a lot of Microsoft development, this kind of feels very normal, resource files where I put images and things like that. And then I've got my source files here. It kind of separates the source and header files into different folders. And then I've got a pre-built Hello World application.
So if you go ahead and run that, then it should just print Hello World and all should be good with the world.
Okay, let's click that. So that's built. Well, that's now running through a debugger. And Hello World. So it's run and it's closed because it just doesn't do anything. Yay! It works. John Mason has a question. Can modern C++ use managed .NET Core code and vice versa?
Depends what you mean by modern C++. There's C++ 20 support with CLR mode is not supported, but below C++ 20, so 17, 14, 11 is.
Okay, because there is, you can do C++.NET, can't you? You can create .NET applications with C++. So John, stick around next week. Next week, we're going to do a bit of a dive into the different use cases of C++. And as part of that, we will be creating some .NET applications. So yes, we can kind of dive into that because you can use the .NET, all the .NET standard libraries, or the .NET stuff from C++ and create managed C++. So that next week's show, we'll dive into some of that. Cool. So I've got my Hello World. Close my window because it says pressing a key to close a window. Pressing a key. It's not closing. Okay. So that build, if I look at my output from build, it did some compilation. It's got a VCX proj, which is just short
so that's
project
the description of your build, which is kind of abstracted away from you in the solution window, so you don't generally have to worry about it.
Okay, and then so that VCX proj is this one here, because you have multiple projects in a solution, can't you? You can have if you have different libraries, you can build those in a put those in
that
different...
top level console application thing is the solution, and then the thing inside is the VCX proj. So if you had a static or dynamic library which you depended on, you could have that in the same solution and it could all be meshed together.
So if I go into actually Windows Explorer, I've got my SLN file, that's my solution file, and then console application 1, that's my project file, and then I guess x64 is the build file. That's the build output. So if I look in there, debug, there's my actual Hello World console application. Cool.
And then the PDB is the debug information.
Yes, the program debug database thing, whatever it is. Yeah. So that, because by doing this, if I actually ship this debug code with the PDB, other people could then step into the code and debug it. Is that right?
Yeah.
Nice. And I've done the same with C#. I haven't done it with C++. So it's good that we can actually ship that and debug it. Jumpman Stick says, I haven't used C++, but I have used SwiftUI, Java, learning a bit of Python right now. And the first kind of program I used was in my freshman year, and it was Game Maker. Oh, nice. So kind of a good range of experience. So yeah, today's all about C++ tooling. We did a show last week where we did kind of a hello world. We actually kind of dove a little bit into language and looked at kind of just some of the basic language constructs. So if you want to check out our Microsoft Reactor YouTube channel, which is just above your comment, I think there's a link to that. We have the stream from last week is available as a video from there if you want to kind of learn how to do hello world. But yeah, great to have you here. It's kind of good range of experience you've got. So hopefully a lot of the concepts we talk about today shouldn't be too far from what you've learned already. Cool. No, great to have you. Awesome. So if I've got the solution file, I've got a project file, I can then configure everything in my project. I mean, I know, for example, we were talking last week about the different C++ versions. And so if I want certain language features, I have to use a certain C++ version. So if I go into my project settings,
right button.
Whoa. Is this one properties?
Big font. Yeah, this is the right one. So
that is big font.
Yeah, it's if you're just using this at home, the font won't be this big. It's just because we configured the font size so it's more visible on the stream. But you can see there the C++ language standard at the bottom there. So if you wanted to, for example, use C++ 20, then you could select that. And then you could see at the bottom there's the preview, which is basically all of the any C++ 23 features we're working on, any experimental standard C++ features will be available under that flag.
Okay. So and if it starts with C++ 14, we kind of don't go back any further than that.
Yeah.
So if I wanted to use some of the cool new ranges stuff that I know you're very excited about, for that I'd have to choose preview to get that to work.
Depending on the version of Visual Studio you're using, yes. The most recent preview release of Visual Studio, which just came out, ships ranges under the C++ 20 flag.
Right.
But the most recent general availability version is under the preview one.
Okay. So it's kind of a little bit of what version of Visual Studio I got in terms of what they actually support against each standard. Because I guess, yeah, a standard comes out, but actually matching that standard takes a long time.
Yeah. So in fact, we literally just hit feature complete for all C++ 20 features, including there were some features which had defect reports in the standard, which are kind of like bugs in the standard wording. So those had to get resolved, and we just shipped a version of Visual Studio which fixes all of those in our version of the standard library.
Which I guess it sounds odd, I suppose. Oh yes, we've written this standard, but there's mistakes in the actual standard. You know, we used to kind of bugs in code, but I suppose, you know, the number of times I've built something because that's what the product owner said we should build, and actually it was a bug in the requirement because it didn't quite do what was wanted. It's kind of the same thing with a language standard, isn't it? You can put bugs in the standard, and until you start using the language fully and actually building compilers and looking at where things could just be mutually exclusive, you're not going to really know, are you?
Yeah.
So, question on versioning from John Mason. What's the latest version, and what version of the STL does that include?
So the latest preview version of Visual Studio is 17.3 Preview 1, which just got released this week. So you can go check that out. And that includes all C++ 20 features and some C++ 23 features as well. Those are available under the C++ latest flag.
Because I guess C++ 23 is still being finalized because, you know, we're only in 2022. So as features get finalized, we can start building up the tooling for them. And then over time, we'll just keep adding it until the final standard is done. And then it's just iterating on that tooling.
Yeah.
Cool. So I guess the downside of that, of course, is if something is in the standard and then eventually they realize that's not good, you could use preview features and then find that when the final version comes out, your code no longer compiles.
Yeah, so that's why we don't introduce the new flag until the standard is finished and until we've reached feature complete, so that everything is guaranteed backwards compatible with all the versions of the tooling. So the C++20 flag is now available because we've finished implementing C++20 and the standard has been stabilized.
Right. Gotcha. Yeah, because that's always the worry with previous stuff is, hey, I'm using this great new thing, and they just take it out, and your entire app is based upon it, and you can't use it. Cool. Jumpman Stick says, cool, I'll go check that out. I love the stream. I sadly have to go to work, so have a great day. Yep, you too. Have a good day. This stream is recorded as well. If you've already gone, then hello, welcome to recording. But thank you for joining us. And Adacola asks, what IDE are you using? I'm a newbie to using Visual Studio for C++. So currently this is Microsoft Visual Studio 2022. So right now we're looking at this for Windows development, but we're going to be looking at Visual Studio Code in a little bit as well. But yeah, it's all versions of Visual Studio contain C++. I mean, I was using Visual Studio 6 with C++ 20 odd years ago. So any version of Visual Studio, and Visual Studio is available in a number of different SKUs. And this particular one I'm using is the Community Edition, which is free. So it's very important to say this version of Visual Studio is free. There are limits, if you work for a company that makes more than like $1 million a year or something like that, there's limits as to who can actually use it. But if it's just you at home, you're doing it in your own time, Visual Studio Community is great, completely free, and that's got all this C++ power for you.
Yep.
So, yeah. And John Mason, diving into the standards here. With standards, sometimes results are undefined or implementation dependent, but it is a useful baseline.
Yeah, so in the C++ standard, a number of things are either undefined behavior or implementation defined behavior or even unspecified behavior. Those three are all slightly different. So in certain aspects, implementations have some freedom in what they are allowed to do, which is in order to account for platform differences and different optimizations and things like that, which different compilers might do. But in general, the standard exists to maintain compatibility between source compatibility between compilers.
So if the behavior of something is undefined, then excuse me, if you take that same C++ code and compile it with the MS Build compiler on Windows and compile it with Clang on Mac, you would expect to get potentially different results out of it because the thing you're doing, it's like, yeah, it's undefined. We don't know what it's going to do type thing.
Yeah, or even if you compile it with the same compiler with different compiler flags, it could do something different. Or if you compile it on a Tuesday, or if you compile it after you brush your teeth, undefined behavior basically says you did some. Don't do that. It's your program's broken.
You kind of hope the compiler would kind of pull you up on that a little bit, but
well, it depends because some instances of undefined behavior you wouldn't be able to catch until runtime without inserting expensive runtime checks. So that's kind of why a lot of undefined behavior exists, so that compilers are free to have freedom to optimize well-formed programs as aggressively as they can without adding in additional runtime costs to make sure you're not doing the wrong thing.
Right. Gotcha.
Of course, there's a
cool,
trade-off there, but yeah.
Yeah, it just seems a strange phenomenon that you can do something. We just don't know what it's going to. You don't know what it's going to do. It's just going to, But as you say, it's with these languages that really compile things, really trying to optimize everything as much as possible. You're going to get that. Whereas with something like Python, you probably don't have anything undefined in Python because it doesn't compile it efficiently. It's just you write this line of code. This is what it does. But that's why C++ is 44 times faster than Python at some of the basic performance tests. So cool. Okay, so that's a Windows type solution file based. If I actually do a new project and just let's have a quick look at a CMake project. So if I go CMake, click on those. And that's got a solution as well, it says, but I guess the solution is just a folder
Yeah,
for
that
it.
just means the CMake project files, which is the CMake files .txt.
There we go. So that's our CMake project one. So if I actually find that in... Yeah, so I don't have a .sln file. I don't have the solution. It's just a folder in my file explorer. There's no .sln that I would open up in Visual Studio. I'd have to, I guess, explicitly I have to go in here and open up here. So this
the CMake lists.txt is the kind of analog to the solution and VC project files.
Okay, so this has got the project name and it says we've got add subdirectory. So that is, I guess, this folder here.
Yep,
which has got
just includes the CMake lists.txt in that folder.
Right. So if I open this one, this says we're adding an executable, which is the program where we compile these files. So if I did more files, there's going to be more in this list.
Yeah, and then it if your CMake version is high enough, then it also says to compile it in C++20 mode. You can see that set property command.
Okay, so I guess CMake 3.11 doesn't support C++20.
Yeah.
Right, and then I've got this CMake minimum required here. So if I wanted to make sure it always worked on 20, I could just set this to be 3.12.
Exactly. Mm-hmm.
Right.
Yeah, and even if you were using an old version of CMake, there's still ways to get it to work with C++20. You would just need to specify the compiler flags yourself.
Right, because this set property, this is the compiler flag. This is saying when you run the compiler, add this compiler flag to it.
Yep, and the compiler flags will be different depending on whether you're using MSVC or the Windows compiler, right? So the Microsoft compiler, or Clang or GCC. So CMake knows which compiler you're using, so it makes sure that it uses the correct command line flags for that compiler. You just have to tell it, use C++20. I don't care which compiler flags you have to set, just get it done. Gotcha.
And then the CMake presets.json.
So the CMake presets, this is like a configuration of your which tool chains you want to use on your system, what targets you want to have available. So you can see here, this is a Windows target. This is like a base target, which is then inherited for this x64 debug target. You can see right at the bottom there.
I see, yeah.
So that will be if you want to target x64 in debug mode, i.e. building without many of the optimizations and including debug information, then you can use this target, and you can see it sets up a few things, like it says what your architecture is. It tells CMake that we want a debug mode build and things like that. So this is to configure all the different targets you want. So if you wanted to target Linux or Mac, then you can use this, and I believe it will also have Linux and Mac targets automatically generated for you at the bottom if you have like WSL set up. For example, WSL being Windows subsystem for Linux, it will automatically work out that you have a WSL installation, and it will generate you a target for that, so that you don't have to do anything to target WSL. You just literally flip a switch and you're targeting Linux, and it all just works.
Right. So I guess for that, then this base here would be like Linux base, and you wouldn't use cl.exe as the compiler, you use like GCC or something.
Yeah, exactly. Yeah.
Right. But then you could put like you've got the binary directory and the install directory and stuff like that. So maybe that could live in a higher level everything base, or
that would live somewhere in your WSL instance.
Yeah. No, okay. So this is kind of like your project file with all the details in there. And then, well, I guess maybe more like a solution file, because if I look up here, Visual Studio's picked up debug release for x64 and x86. So this is being picked up from here, yeah?
Exactly, yeah.
So if I were to go in here and say manage configurations, it literally opens up this file.
Yeah.
Yeah. So John has some questions. He says, I'd like to see some of the debugging capabilities in one of these sessions. Also some discussion of logging. After the Log4Net meltdown, a lot of us are looking at alternatives and SBOMs. Don't know what SBOM is. Yeah, maybe. I mean, so next week's session, we are doing a bit of a show and tell and looking at some of the use cases. So maybe we could kind of talk about logging then, if there's a standard C++ logging, or just dive into some debugging next week.
Yeah, we can certainly look at that. I can give very, very quick things. There is no standard C++ logger. There are several widely used open source logging libraries. And for debugging, Visual Studio has a lot of debugging features, even just in the most recent versions. Like we added dependent breakpoint support, which is this breakpoint should only trigger if another breakpoint has also triggered. So it lets you kind of have dependencies between breakpoints. If you have something which, like a bug, which only occurs if some other line of code has been run, you could set a dependent breakpoint.
Ravi clarifies SBOM software bill of materials. So yeah, actually knowing that if I use this depends on this. So I actually completely understand the whole chain of software. Thank you for the clarification, Ravi. Appreciate that. So actually for debugging, I guess a quick demo. I could just go because I can just put a breakpoint here.
Yep, should just work.
And I run this, and it'll run. I'll hit this, and it will go through and hit the breakpoint. And obviously, I can do stuff. Is there edit and continue support?
Yes. So I can't remember what the CMake support is like right now, but in fact, I think I can see the hot reload button up the top, that fire icon. Yes, that one, hot reload. So hot reload is a feature which lets you make changes to your application while it's running without even necessarily being stopped at breakpoint or pausing your application. And then you can immediately see those changes running. It's just recompiled and loaded into the running program.
So if I were to change this from hello CMake to hello reactor,
yeah, I think I can't remember. You might have to use so MS build support for hot reload is all there. I think for CMake support, maybe you have to use the MS build generator. I can't quite remember off the top of my head.
Okay, so there is So that's something cool. Maybe that's something we'll dive into a bit then next week. The hot reload, because I know hot reload is kind of a big thing in the mobile world. I used to do a lot of Xamarin development, and the idea of you could just change your UI and update on your phone to kind of save redeploying was massive. So it's here for C++. So one for next week. We'll dive into that next week. Cool. So as always, with all the great questions we've got, things are going a bit slower. This is Windows. Visual Studio is very much Windows. Now, I'm a Mac person, as people will know. Look at me. Look at my lovely Mac. I work for Microsoft, and I have a Mac. So what about different support? And in fact, that actually leads nicely into this question from John saying, can I build the Linux executable on my Windows machine, or do I need to compile on a Linux box?
So I think you can maybe use the Clang tools on Windows to generate Linux executables. But you can also target WSL and have just use GCC or Clang within WSL, or you can target a remote Linux machine as well. I've never tried building for cross-compiling for Linux on Windows using the modern like Clang tooling on Visual Studio. I think my intuition says it's possible, but I haven't tried it.
So I just have to dive in with an apology. So I live in middle-class suburbia in America. So obviously at 8:45 in the morning is when the gardeners should turn up and activate their petrol-driven tools. So if you hear strange loud noise in the background, which I'm hearing right now, that's lawnmowers and leaf blowers and other such fun. So apologies for the background noise. They always do it at the most inconvenient times. Cool. Okay, so yes, I'm on a Mac, but obviously Mac and Linux is how do we build on there? We can't run Visual Studio, so Visual Studio Code has C++ support via extensions. I've dabbled in that a little bit with embedded development, but yeah, what are the differences between what we can do on Visual Studio Code compared to Visual Studio?
So the Visual Studio Code, if you've used Visual Studio Code for other languages, the experience should be fairly similar to what you'd expect. There's like syntax highlighting, there's language server support, so there's similar kind of IntelliSense experience that you might expect. There is debugger support as well in Visual Studio Code. It's not quite as fully featured as the one in Visual Studio itself, but yeah, if you've used other languages in VS Code, the experience should be similar.
Okay, so if I go, so we have this whole, if I go to the extensions tab, C++, we have a whole C++ extension pack that's got the C and C++ extension. It gives all the IntelliSense, the debugging, the code browsing, all that kind of stuff. We've got some themes. So if you want to style your UI, and then we've got support. That brings in support for CMake. So I guess this is to actually understand the CMake files we looked at.
Yeah, that's the language server support for editing the CMake files.
Yeah, so we kind of get all the IntelliSense and autocomplete and all that for CMake. And then there's CMake tools.
Yeah, CMake tools is for actually integrating the CMake build into Visual Studio, so that you could just hit a button and it runs CMake and builds your executable or your libraries or whatever.
Oh, nice! When you press F5 to run it, they use the CMake tools to do that. Cool. And Doxygen, which is generating documentation, and better C++ syntax. Gives you syntax, bleeding edge syntax highlighting. So that's get all the syntax highlighted for all the cool things.
Yep.
Okay, so in theory here then, if I go in here and just go C++, can I create a C++ application, or do I have to do it from?
So there's, I haven't used the startup experience for Visual Studio Code in a while, but you could just create it really depends on what build system you're going to be using. So if you're using CMake, then you could create a source file and a CMake lists.txt, for example.
So if I just hop to my desktop and create a folder here, and then let's just open that here. My desktop. And then if I just start by creating a app.cpp, you can tell I did too much Python calling it app. And then, hash include, I'm just going to find and copy and paste a hello world because I'm lazy like that. So if I do something like this, if I want to then run this, I could do this from the command line. I could use clang from the command line. But you're saying if I create the CMake file, so what's it called? It's CMake
lists.txt.
What's the capital? Is it any particular capitalization for it?
Yeah, CM capitalized and lists capitalized, L capitalized, .txt. And then you would need to have a few things in there, like the minimum version, and then add executable. But I think we won't have time to talk about VC package if we go through for all of that. I think there is more getting started stuff for Visual Studio Code, which eases some of this as well. But I can't remember the details of it right now.
Looks like there is a.
Oh yeah, it's picked up your
They've got Clang installed.
Yeah.
But
CMake you don't have CMake itself installed, so you'd have to get CMake.
Okay, so it's not just about configuring VS Code. I have to make sure I've got all the tools installed. Whereas Visual Studio, I click install, and it just installs everything for me. With this, I have to make sure I've configured up my environment as well. So I've got, they've got GCC, I've got Clang, but I don't have CMake.
GCC is just a symlink to Clang on Mac.
Yeah. Okay, so I have to, brew install CMake, and then I'll be able to use all the tools on here to make it all work. So, so are there any limitations with using Visual Studio Code?
It really depends what you're looking for. Like you can use Visual Studio Code for all of your C++ development if you like, and there's other extensions for make files. There's an extension for embedded development, which we just released as well. So yeah, you can definitely use VS Code for all of your C++ development.
Cool. It's just because obviously we rely on CMake rather than the whole Visual Studio UI for doing everything. So if you're an MS Build type person, then obviously Visual Studio is the best one, but for everything else, it's VS Code. And John Mason actually says, slightly off topic, I assume I can do all my coding in VS Code as well, but it's not as seamless as it would be. Is that correct? So I guess, yes, it's not as seamless because you're relying a lot on editing files like your CMake list.txt. You don't have kind of the whole powerful UI to configure everything.
Yeah.
Cool. Okay. So I definitely want to take the last 10 minutes that we've got here to talk about stealing other people's code, because I feel that's a very cool thing to talk about. So there's a thing called VC package, VCPKG.
VC package, yeah.
VC package. So this thing here, do you want to tell me all about it? Because I like using other people's code because I'm lazy.
Sure. So it's a package manager for C and C++. It supports Windows and Linux and macOS. It has, it says over 1,500 there. I think it's over 1,700 now. Open source packages, which you can just use. You can write your own packages for it. You can have your own private packages. There's support for binary caching. There's you can install packages system-wide. You can install packages per project. You can specify what versions of packages you want. If you're familiar with something like NPM or Cargo or whatever, then it should be a reasonably familiar experience.
So it's basically like, say, doing pip install, whatever. It's that. It's just for C++.
Yep.
Nice. And then packages-wise, if I just have a look at the packages, 1,910. You were out by 200.
Well, some of these are not available for all platforms as well. So I think that might be taken into account for counting purposes.
And John says, wow, C++ has a package manager now.
Yeah, so there's no standard package manager for C++. The two most widely used ones are VC package and Conan.
And then Ravi says, back to SBOM, software bill of materials. Does VC package have security built in for integrity?
What kind of security features would you be looking for? It's like these are all open source packages, so that any do you mean things like ensuring that there's no like no one uploads a malicious package or edits a package such that it goes and downloads some other code or things like that?
Because I know NuGet has things like that. So you get let's see, you get like signed packages on NuGet. So people sign to say that yes, I did this package. There's no guarantees that the person who signed it actually created something, something good, and it was signed. It could be signed by somebody that's still got stuff in there. So if I got examine forms, for example, that is it's a reserved package by Microsoft. It's owned by Microsoft, so you've kind of got that. People own that, and I know that you can. Just trying to think what would be other. I'll search for some logging packages. I mean, Log4Net, for example. You kind of get to see a lot of stuff about it. I know that if I actually look at, sure, there's something here, but with NuGet, you get signed packages. So you actually sign. People can actually sign things to say that yes, this is signed by me. But of course, there's the, all it takes is someone to get into the source code that's behind it. Maybe a signed package to say it's signed by Log4Net, but if somebody actually gets into the source code repository, and changes it.
Yep.
You just don't know what's going on. So
yeah, so I believe the current things are that all of the VC package supports different federated repositories essentially. So there's the main VC package repository, which is completely managed by Microsoft, and no changes to any package can be made without a pull request being looked at by someone on the team. If you then want to use other repositories, other sources of packages, then you can do so at your own risk. There are things like all of the packages are hashed, and the hashes are stored in the port files, which is like the descriptions of the packages. So if there's any mismatches, like man-in-the-middle attacks of some package being the contents of the package being swapped out, then that can be caught. I don't think there's support for signed packages right now. I don't know myself about what's coming in that area.
Right. I guess it's going to be an area that's going to be expanded on because there's been so many supply chain attacks.
Yeah.
You know, you just don't want to be in that situation where, you know, the whole SolarWinds thing, you know, if somebody gets something into one of these packages that's used in 100 other places,
yeah,
that's problematic. It's John saying signing doesn't prevent issues like the log4net bug, but doesn't show you have a specific version from a known entity, which I guess if you're saying you can have your own package library, essentially, then your own internal dependency management teams can build that themselves and have, right, we only support this version because we've tested it. We'll just add that to our own VC package, and then you just they manage that. So rather than go to the Microsoft one, you go to your internal approved one.
Yeah, and there's also the every build. So VC package is essentially frozen at any given commit, and every single commit to the VC package repository runs the entire test suite of all of the packages which are contained.
Yeah,
and including testing them against each other.
So Ravi says, yeah, GitHub has Dependabot to verify vulnerabilities, etc. So there's no real Dependabot type thing here. But if you've got like Absa, for example, it's on GitHub. And so you could go here and then just hope they're running Dependabot on here to show any security vulnerabilities. So if I go security here, view security advisories, there's none. So at least I can say, okay, Absail, according to GitHub, there's no security advisories. So there's nothing that depends upon that's known vulnerabilities. So we kind of got that little bit of vulnerability checking, dependency checking all the way through. Cool. John asks, will all of these sessions be available on YouTube? I can't always make it live. Yes, all of them on the Microsoft Reactor YouTube channel. We can just drop a link to that in the chat. So we did one session last week, one today, and then one next week. So if you can't make it for next week, they're all available on YouTube. All of the Microsoft Reactor live streams go on our Microsoft Reactor YouTube channel, which has just been dropped in the chat. Thank you, Firas, for that. Cool. Okay. So we're pretty much at time. I do want to just wrap up with dropping in a couple of links for folks. So first thing I want to drop in is if you want to get going with Visual Studio, just trying to get this dropped in the chat. If you want to get going with Visual Studio, this link here will take you to how to get going with C++. Oh, no, that's the Visual Studio Code one. That'll take you to how to get going with C++ and Visual Studio Code. It talks about the extension, how to install it, how to install compilers if you don't need a compiler, check your compiler version, and all that kind of stuff to get going all the way through to your first hello world, build it, get it done, get it running, and then links to a whole load more cool tutorials. We've also got another link I'm going to drop in, which is, this should be the Visual Studio one. Yep, so this is all about how to develop C and C+ applications in Visual Studio. So links to download the different versions. The community is the free one that gets you going. And then all the details about how to do it. Cool cool, funky videos on there, and kind of just great stuff to get you going. And then finally, last little link I'll drop in takes you to VC package, and that so you actually have a browse through and get going with VC package. And it's, it runs on all the platforms, Windows, Linux, Mac. It's literally, you clone it, you bootstrap it, and then you just install the packages. So yeah, we are at time. So thank you very much, everyone, for joining this session. I hope this was a really informative show for you. We'll be back next week, Sy and I, where we will be diving into some use cases of C++. For John, we'll do some debugging next time. We'll look at .NET, just some of the use cases around everything from gaming to desktop to development, and just have a bit of fun just looking at the different things we can do with this incredibly powerful language. So John says, good session, knowledgeable presenters with useful material. Knowledgeable presenter. Sy has the knowledge. I'm not knowledgeable about this at all, so I'm really thankful Sy was able to join us for this. So, yep, Ravi says thank you. Yep, you're welcome. Glad you could be here. And Irregular Robbo, hey, welcome back. Programming without pointers. Yes, we'll make sure we do no pointers next week at all, because as we know, pointers are bad. Awesome. Well, with that, thank you very much. Really appreciate you taking time to be here. We just dropped a link to our survey in the chat. When you click on the survey, it asks you for an event ID, and the event ID for today's session is 16129. Please fill in the survey. They tell us what you like, what you don't like, so we can make sure that the shows that we put on for you are exactly the kind of content that you want. But yeah, with that, Sy, thank you so much once again for joining me. It's great to have your knowledge and experience to share with everyone. But otherwise, thank you, everybody, and goodbye. Enjoy the rest of your day, however much of that it is.
Thanks, everyone. Bye.